very much, and thank you everybody for staying this afternoon to hear me say a few words about Croatia. And I guess it was about a month or so ago when we realised that we committed to speaking here at the Global Hotspots talk. I suddenly thought, well, okay, what's the hottest hotspot that I could think of? And it just has to be Croatia, and that's why we need to talk about Croatia. And the reason for talking about it is that, well, I suppose picking up another of David's original themes at the start of this of the conference today, is exploration getting too difficult? Is it getting too expensive? Well, it might be getting harder because we're asking harder questions of ourselves when we do our exploration, but to be honest, our tools are getting better. So we're more able to answer these hard questions that we ask. And the second thing is, is it getting too expensive? Well, so's the product price. Certainly since my career started, the product price has gone up by tenfold, at least. So it might be getting more expensive, but is it getting too expensive? Well, I suspect not, if you can work in a country where the water depth isn't particularly deep, where you're looking for oil as a product, and where the geological solutions are all there present in the seismic. So, this is why we need to talk about Croatia. Okay. So this first slide that we have here, and it on the right-hand side, you see a map of the Adriatic. You can see the wells that have been drilled on the Italian side of the Adriatic. Lots and lots of wells, and the number of wells that have been drilled in the offshore Croatian side of the Adriatic on the right-hand side here. Not so many wells. And of course, you know, geology being what it is, there may be a good reason for it, but I'm hopefully going to show you some information this afternoon which might suggest that there isn't a very good reason for that at all. And in fact, now with our new technologies, we can start to unlock the prospectivity that was searched for before in the offshore of Croatia, but not found. Croatia itself is now in the EU. Kind of funny because I suppose that part of the world was Europe at one time, and now we've just let it back in again, which is great. But it's a very stable government. And one of the things that struck me from the talk on Mexico this morning, where the suggestion was that you can't do a license round with 5 people. Well, in Croatia, they did it with 3 people, and they did it in a year. And it may be not quite as complicated as trying to deal with the internal politics in Mexico, but it shows what can be done if the political will is behind the opportunity. So what they did in April 2013, they decided to have an offshore license round, and the oil minister, new guy, wanted to make his name as being the man that put together this license round, and he made it happen. So he identified what all the various bits are that you need to put in place, like a new mining law and so forth, and looked at the available offshore data and decided that there wasn't enough seismic offshore to allow companies to really get excited about the offshore, so he got some shot. And then put in the infrastructure and the legal system that allows a license round to happen. And he's done that all within a year. So on April the 2nd of this year in Zagreb, it was a big media, it might have been, I have to say, it might have been a low news night in Zagreb, but it was a big media event in Zagreb, which was the opening of the license round. So I've got a little bit of film that was from Croatian TV that evening, and it shows the minister. That's the minister there. He's about to open the license round by pressing this button, and there we are. And it says all the things that they put in place: licensing conditions, regulatory framework, licensing criteria, seismic data is in place. We apparently found the hydrocarbon prospectivity already, and that we are ready to go with a license round. They also very handily showed where Croatia was, for anybody watching Croatian TV who wasn't sure. But they then showed where the license blocks were going to be. Each of these license blocks, there's 29 of them, going to be about 1,000 square kilometres in size. And we also need a lot of footage of applauding international oil executives, very smart international oil executives being singled out here for close scrutiny and fame and fortune. And this is the data room, which was the Croatians have put together, where they put all their old data for oil companies to come and see. So this was the very last thing, probably a complete mystery to most people who are Croatian watching this on their TV as to what that was about. But it was the first license round is now open. And I was stunned when at this event. I was just stunned at how slick that was for a company to put together, for a country to put that together just within a year and got this license round moving. So basically all of the various bits and bobs that you need for a license round are in place. You know what the commercial terms are, you know what, there's a lot of information that's available for oil companies. In fact, the commercial terms are really good, especially compared to what we heard this morning from Mexico. Instead of 70–80% of the take, the government's looking at more like 50 to 55% of the take, depending on whether it's oil or gas. And you know, on the world scale of government take from oil projects, that's actually pretty good. So the question that we asked in Spectrum when we had the opportunity to acquire some seismic data in Croatia was, is there something fundamentally wrong with the hydrocarbon system on the Croatian side of the Adriatic compared to the Italian side? The early exploration was focused up in the north, in this what we're going to call the northern basin, where a lot of gas fields have been discovered. There's about 20 gas fields that have been discovered, most of which are on production. And it's relatively shallow fields and dry gas, so probably biogenic gas. So this was the flavour of exploration in the 60s and 70s, looking for these dry gas discoveries. And these discoveries were made on both the Italian side of the Adriatic as well as the Croatian side of the Adriatic. So Croatia has an experience with the oil and gas industry. It's got some big fields and exports. Some of its gas goes to Croatia, some of its gas goes to Italy, but there is infrastructure in there. But perhaps of more interest to more of us in the room is the oil potential. And to date in the Adriatic, the discoveries have been made on the Italian side of the Adriatic. And we're going to have a look at what those discoveries are and how they work, and then compare that with the geology on the Croatian side of the border. And the reason for following that is that that's exactly what the Croatians did. Ina Naftaplin, who had almost had the monopoly, not quite, almost had the monopoly to explore on the Croatian side. They looked at where the oil plays were working on the Italian side. They looked at the geological models there and then extrapolated them across to the Croatian side and tried to find the same plays over there. Exactly the right thing to do. Unfortunately, they didn't have the tools to do that, and that's what I want to take us through. So there are three basins that we should be talking about. The northern basin, which is where all the shallow gas up in the northern part of the Adriatic. The central basin, which is a slightly more complicated, but actually not that complicated, central part of the Adriatic. And then the southern basin, which is in deeper water, pretty much unexplored. And it's drop dead gorgeous even from a long way away. So let's just look at the play systems now. The first play element that we need to think about when we're looking at this sort of new basin is the source rock. What's the source rock going to be? And in the Adriatic, the dominant, not the only, but the dominant source rock is late Triassic source, a Sabkha algal mat type of deposit that is that outcrops both in Italy and also onshore in Croatia, and it's found in some of the wells drilled offshore Croatia that have been drilled deep enough. And this actually provides the dominant oil-prone source rock in the southern part of the Adriatic. Once we've found the source rock and we've understood how to chase that source rock, we'll also be looking at the reservoir. Now, the geology of the Adriatic really splits into two easy-to-digest chunks. From the Triassic right the way through to the end of the Cretaceous, it's all carbonate. It's a big carbonate margin. You've got carbonate platforms and carbonate basins. And then after the end of the Cretaceous, or just a bit later in the Eocene, it's all clastics and no carbonates at all. So something happens at the end of the Cretaceous that turns this basin from one sort of basin into a completely different one. And what happens is that Italy bumps into the Alps and we form the Po Valley and we start draining the products of eroding the Alps. We start draining that into the Adriatic. And until the end of the Cretaceous, that didn't happen at all. As soon as it starts to happen, it just dominates the whole basin, fills up the basin with clastics. So let's put this in some sort of context. This is just a topology map of the Mediterranean and the surrounding areas. And the Adriatic is a really neat little basin. I don't know many basins like this. There's perhaps little bits of the Black Sea like this, but there's not many basins that have thrust systems on both sides. It's a little basin that's trapped between two thrust systems. So we have a thrust system here, the Apennine Apulian thrusts that dominate the geology of Italy. And then we have the Dinaric thrust system, which connects through into the thrusts and the tectonics that control the geology of Greece, but it's part of that system. The Dinaric system on the east side of the Adriatic. And these two thrust systems are both pushing at each other. So one day, for sure, there's going to be no Adriatic. But at the moment, there still is, and we're blessed by it. And, yeah, that's where the thrusts are moving. Okay, and when we look at cartoons that we see, or cartoons, illustrations, geological cartoons, across the Adriatic, we often see this type of diagram that we've got at the bottom of our screen here. And this line would go, it's a schematic line that goes from onshore Italy across the whole of the Adriatic and then up into Croatia and onshore into the Dinaric fold belt. And it shows the complexity. On the Italian side, lots of thrusts, imbricate thrusts, and anybody who's ever drilled wells onshore in Italy just knows how complicated it can be, even knowing which thrust system you're going through at any one moment, let alone where the structure is that you were supposed to be drilling for when you started on the venture. So really complicated geology onshore in Italy, and really complicated geology onshore in Croatia. And it's just the same thing right through the Dinarics, where you've got these multiple thrust systems and you're trying to drill for sub-thrust plays, really complicated stuff. That's not what we're going to be talking about at all, because what we're looking at is the offshore Adriatic, and it's this section in the middle where we're not seeing any of that complexity. We're not seeing an awful lot of complexity on the eastern side, on the Croatian side, because we haven't really got into the Dinarics. And we're not seeing an awful lot of complexity on the western side, because we haven't really got into the Apulian thrust system. So we have really quite a simple system. And on this seismic line, which goes from almost at the coast of Italy here to the coast of Croatia on the right-hand side, what dominates it are this section here, which is the top of the Cretaceous is here, runs across the way. And so it's dominated by a tertiary sag, which is the foredeep, basically the basin in front of a big thrust system that you can see here. It's that big foredeep that dominates that system. And on the Croatian side, you don't see this tertiary, well, it's a late tertiary foredeep, it's not Pleistocene. On the Italian side, you don't see that. But what you see is an earlier one, an Oligocene foredeep that was related to the Dinarics. But apart from that complication, there's no real deep complexity to the geology here at all. And that's the first thing. You're not looking at sub-thrust plays. You're not looking at heavily tectonized sequences. So what sort of geology are we looking at? I'm going to focus now not so much on the shallow biogenic gas, but on the oil plays. So on the Italian side, a number of oil discoveries have been made. The Rospa Mare field, which is located here or located there on the coast of Italy, is an intra-platformal horse block. So we're at the carbonate margin, and we're behind the carbonate margin on the platform, whereas the little horse block has been allowed to be exposed and through calcification processes developed really good porosity. It's little unusual situation, and but it's within the platform itself, or the carbonate platform. But interestingly, just around this carbonate platform where it's been identified, here's Rospa Mare on the platform itself. There's a margin here, which is the edge of the platform margin, and then in front of that, down slope from that, you get remobilized carbonate deposits, such as the Elsa field here. So this is bits of the carbonate platform that have fallen off and just fallen down the slope of the carbonate bank, and then generated little porosity units. And that's the key for exploring this type of geology. It's carbonate platform geology. Whether you're on the carbonate platform itself or in front of it down into the basin, you're always trying to find porosity. For some reason why there should be some porosity within the system that might provide a reservoir. If we go a little bit further south now, towards the southern tip of Italy, still on the Italian side of the Adriatic, there's another sort of discovery that's been made. And this is right at the carbonate platform margin, looking for build-ups of reefal build-ups actually on the platform margin. And there's a couple of discoveries, the Giove and Medusa discovery have been made of that form. And this is looking for reefal build-ups at the platform margin. And then down in the basin, the Elsa analogue would be in here, but down in the basin, re-sedimented carbonates down in the basin have also got some porosity in them, and that's where we've got the Ravesti and the Aquila type of analogues that we're probably familiar with. So this is the type of geology that's been explored for on the Italian side, and this is the hydrocarbon system that seems to be working. So this is what the Croatians took as their model when they look at the Croatian side. First off, let's just think about what it's like at that platform margin. It's actually a very high energy environment. So there's very shallow water, and you can see the corals, the beautiful corals who are growing there. The interesting thing about the Italian platform margin is that it's almost unique in that it stays put. And so if one was to imagine oneself in a little time machine, now you go back to the Triassic and put on your swimmers, get out and you wade out into just slightly, not particularly deep water. You could stand at that platform margin like this guy is about to do. Just stand there on the seabed at the edge of the platform margin. And the weird thing about the Italian margin is that you could stand there for 130 million years and you'd still be at the edge. In fact, you wouldn't have to move at all. So you'd still be at the edge of the platform margin. It's just one platform margin that grows on top of another, on top of another. Just keeps growing. It doesn't move at all. Now, that won't be the same on the Croatian side because the Croatian geology is slightly different. On the Italian side, we're depositing these carbonate platforms on top of, at most, in terms of evaporites, at most it would be anhydrite, which isn't very mobile. On the Croatian side, you're depositing these carbonate platforms on mobile salt and thick sequences of mobile salt. And I think more salt was present on that margin than anyone's really realized before. And when we look at the geology on the Croatian side, I think we can start to feel that this was actually a very salty basin. It becomes key to understanding the exploration strategies that you might adopt in Croatia. So we're depositing a kilometre or two of very heavy carbonate onto a salt sequence. The only thing from all of my travels around the world and all the geology I've ever seen, the only thing you know about salt is when you do that to it, it does not stand still. And from quite early on, you'll be forming salt walls, salt diapirs, and it would be really heterogeneous. And this will be very different then on the Croatian side in general, on the Croatian side to the Italian side, where the carbonate platform just stays in one place and it just stays there for 130 million years. On the Croatian side, we'll form lots of little mini basins, and there'll be very heterogeneous platform edges. This is particularly true of the central basin in Croatia. It may not quite be true of the southern basin, and we'll show you an example of that in just a minute. But this is the thinking that the Croatians took on board when they started to map out these facies belt. And this was a map that's produced by a Croatian guy called Grandage, who seems to be the godfather of mapping carbonate platform margins in Croatia. So we've mapped on the Italian side through Rospa Mare and Elsa up here down to Aquila and Giovi. We can nail this platform margin on the Italian side pretty well. And on the Croatian side, he's mapped it along here. And he's made a good stab at trying to find out where that platform margin is. And finding it is absolutely critical. So if you think you found it and you haven't found it, it'd be really easy to drill a well into the middle of a carbonate platform where there's no porosity. And then, of course, you've got a duff well. It'd be really easy to drill on the wrong side of the carbonate platform into the basin and then find some basinal sediments that you weren't expecting. It'd be really, really easy. So what sort of tools were these lads working with? The tools that they were working with was seismic that wasn't really up to the job. This is one example, of which there are many, a published example of the sort of seismic that the Ina Naftaplin and the researchers trying to hit that carbonate platform margin were using. And it looks really convincing because there's pink stuff, which is clearly a reef, and there's green stuff, which is clearly a slope sediment. What could go wrong? There's another example here. Looks slightly less convincing when you get up close to this one. But anyway, what they were trying to do was to find some reef sediments on the seismic. And it's desperately difficult when your seismic is just full of migration smiles and multiples and it's just not up to it. So we took a sample. Part of this bid round process, there's a data room that's set up in Zagreb for oil companies to go down to Zagreb and look at all the old INA data and figure out what the prospectivity is. And this is an example of the data that will be in that data room. So it was passed from INA Naftaplin to the government as being the best example of the seismic data in this particular region. And it's okay, you can see some stuff. You can see the seabed, you can see the Messinian in here, and then you can see something else in there. And you might say, well, that's probably the platform margin. I'll put some sort of lineament down here, and this could be a slope sediment. And that's the sort of thinking that they had to do, because this is the only tool they had. When we reprocess this line, we've got a completely different picture. And of course, the platform margin is here, the bit that you can't see because it's full of reef, and so it's not really reflective. The high reflectivity material back here is in the platform margin. It's the stuff you don't want to drill into. So it's absolutely critical to have good quality data in order to understand where this platform margin might be. And as a consequence of the fact that there just wasn't a data set available to actually do this sort of work, we had to acquire some more data. So we acquired about 14,000 kilometers of 2D data in the region. And I'm going to show you a few examples of what we can see. And this is stuff that has never been seen before. So the first thing that comes across, this is a strike line. So it's running virtually north-south up and down the Adriatic. The first thing that you can see on this line that could never really be seen before is this down here, a set of reflectors at some considerable depth. You probably can't read the scale, but it's about 4.5, 5 seconds. And because a lot of this is carbonate platform, that's actually quite deep. It's about 5.5 to 6 kilometers. And the important thing about that reflector is it's telling you where the source rock is. The source rock sits just on top of that reflector. So you've got a source rock that's down at 5.5, 6 seconds. And as we'll see as we come through this talk, we're going to talk about the geothermal gradient not being particularly high, but if you bury your source rock down to 6.5 kilometers, it's going to be mature for oil, in fact, probably for oil plus gas. So that's the first thing that couldn't be seen before, and it gives us a clue for how to look for oil prospective parts of the offshore Croatia. It's by mapping out this source rock. Other things that jump out from this particular seismic line, the red line here is the Messinian. That's a Messinian unconformity that's quite easy to map. And on top of it are the tertiary or the Pleistocene deltas that are coming down from the Po Valley. And as I said before, since Italy bumped into the Alps, the Po Valley starts to drain all this clastic material down, dropping it in the Adriatic. And a whole series of deltas have built out and built down through the Adriatic. In the northern area, this is where the shallow Pleistocene gas is found, and it is really, really shallow. In the central basins and down in the southern basins, they are completely, as far as we know, unexplored, even though we can see quite a lot of anomalies within those sections, which are soft kick anomalies that implies that they might be prospective. But these are unexplored Pleistocene deltas at the top of the section. And then within the main body of the section, this non-reflective material here is non-reflective because it's carbonate platforms sitting on top of carbonate platforms, no acoustic impedance contrast. But right at the top, you can see there's a change in character into a very mottled, like a broken type of character. And this is going to turn out to be absolutely critical as we go on. So there's the Triassic source rock. The other thing is, as we've been mapping this around, we actually put an awful lot more salt in this section than anyone's ever put before. And we can see clear diapirs and clear diapiric structures. We'll perhaps have a look at those in a couple of slides' time. And this line is a dip line running from east to west across the basin. Shows the big difference between, that's the Italian side of the basin, this is the Croatian side of the basin. And on the Croatian side, we have this deep basin in here. The Triassic source rock is clearly indicated just here. That's a very thick basin which has got an Oligocene 4 deep sitting on the top of it. So going back to that diver fella who's standing on the edge of the carbonate platform from the Triassic, if we give him enough time, then he's going to stay on the Italian side from the Triassic right through to the Cretaceous, so 130 million years. This guy isn't going to stay where he is for 130 million years. He can't hold his breath quite that long. But what he's going to do, he's going to dive off this carbonate platform, and it seems a bit of a facile point I'm making here, but it does have a point, I promise. So when he dives off here, he's not diving off down a gentle slope, he's diving off down a cliff. This isn't a fault, it's a sedimentological feature. It's a deep, deep feature because these carbonate banks were very, very steep, and we can see them in the seismic now. This is an example from in the southern basin, a dip line running east-west. And that's the top of the Cretaceous here, and that would have been the carbonate platform margin exactly there at the end of the Cretaceous. So that brave chap would have been standing right here and then diving off down this really steep slope. These are really, really steep margins. But it's absolutely critical to know where these are before you start drilling for them, because you wouldn't want to go on the wrong side of it, well, at least not on purpose. And what you find at the platform margin is that, in general, is the character of the seismic gets a little more broken up, a little harder to see the reflectors, and that's because it's so full of porosity. And that makes this really quite interesting, because we have a carbonate platform, it's completely undrilled, sitting under a pile of clastics, which is the Pleistocene and Oligocene clastics that have been pouring into the basin in the latter part of the tertiary. So a good seal onto a carbonate platform which is going to have porosity, and these are big old features. Where they're sitting is over the Triassic basin, which is buried down to about 6 to 6.5 kilometers. So it's certainly going to be generating hydrocarbons. These are perfect hydrocarbon plays, and they're just sitting undrilled in the southern part of the Adriatic. Okay, this is the orthogonal line of 90 degrees, 90 degrees to that previous line. This is now running up towards the Adriatic, and you see again the platform margin here in the deep water setting of the basin. Now, it's possible that there are plays down in deep water. They will be relatively deep, but there will be plays here because the material that's eroded off the platform margin edge can be deposited down here and retain its porosity, and that's how Aquila and Elsa and so forth work. So there will be plays down here as well, and they will also be sitting over this mature oil source rock. But they're not the only plays in town. There are also very big structures out in deep water, as well as the sedimentological structures. So there's plenty to go for, not just carbonate plays, but also tertiary plays overlapping against some of these big Cretaceous structures. But one of the wonderful things, absolutely wonderful things about working in Croatia is that there's so much data that's available for a license round. So here we have a whole bunch of acreage that's never been licensed before for explorers, but not only is there now a coherent seismic data set, but there's also a coherent well data set, because all of the wells that have ever been drilled offshore Croatia are available for oil companies to get hold of and use in their evaluations. And they're really, really useful. Here's an example from the central part of the basin. And this well here drilled through Carbonate platform at the end of the Cretaceous, and this well here drilled through a basinal type of sequence. Normally, we don't have an awful lot of material from these wells that tell you exactly what facies you've drilled through, what sort of carbonate facies you've drilled through. So sometimes you have to look for analogues. And again, Croatia does this in spades, because you can just go onshore and you can see these same sequences exposed at the surface. And so this is the coast of the Adriatic here. If you go onshore Croatia, you can basically walk around the geology that is present in these wells, and you can see on the seismic. There's an example from some workers from the Geological Institute, of the Geological Survey, effectively, of Croatia, as they're mapping the fleesh, the tertiary 4-deep sediments around the basin. But they go around, they collect up these examples of the rocks that they drill through, or that we see on the seismic, and you can then hold something in your hand to allow you to crystallize your ideas. So in this particular example here, which would be 2 samples from this type of location, we can get a sample of the fleesh deposit and fine-grained clastic material, so mudstones and siltstones, and then just underneath it you can get a deposit from near the edge of the Carbonate platform, and you can have some samples which are porous, they're rugose, corals, and other shelly deposits, which but much higher energy deposits. And then in the same sort of situation, but located down in the basin, we go through a facies which we noted on a previous seismic line, this wormy, broken up type of facies in here. And when you look at what that is in the field, that's a breccia, so it's broken fragments of the Carbonate platform deposited at the bottom of the basin, still retaining porosity. So we can use the geology onshore, we got the full well data set, and you've got a modern high-resolution set of seismic to combine in your evaluation of these license round blocks. So, last point, really, so I suppose the first thing that we really emphasised there is the presence of reservoir and how you've got the information to go and look for your reservoir, go and look for your porosity. The second thing, of course, is you've got to find some hydrocarbons to put in your reservoir. And one of the things that almost everybody knows about the Adriatic is that it's a very cold basin. Yeah, it has a very low geotherm. So as you go into the earth, it doesn't heat up very fast as you go into the earth. And that can be a problem for a source rock if it's too shallow, because it won't get hot enough to start generating hydrocarbons. Well, it's not actually that cold. The geotherm, on average, throughout the Croatian margin in the offshore is about 20 degrees centigrade per kilometre, which is globally you can get geotherms which are up to 100 degrees centigrade per kilometre. So it's not the hottest of basins, but 20 degrees centigrade per kilometre is plenty enough if you buried your source rock to 6 kilometres, because then you've got a temperature of about 120 degrees in your source rock, and that's plenty hot enough to be generating hydrocarbons. And in fact, there is an example of oil recovered from offshore Croatia, and it comes from this well here called Vlasta 1. And it was the only well that's really been drilled deep enough to go into the Triassic, and it recovered a small amount of moderately light oil, about 29-30 degrees API oil. But it couldn't find a reservoir because it wasn't targeting, well, the seismic quality at that time wasn't good enough to try and target the reservoirs. But it did prove that there was a working hydrocarbon system in that region. And in fact, we've done some modelling now. If we go back to our previous example where we were looking at the geology of this section up here, we've done some modelling of the source rock that we can see at the base of that section here. And the quite surprising conclusion that we've come to is, even though it looks like there's some tectonics in this region, the tectonics are caused by salt halokinesis, not by basin inversion. So the source rock has never been deeper today than it is today. It's at its deepest today. So one of the worries that one might have had is that the source could have been starting to generate hydrocarbons 50 million years ago when there weren't any structures or any traps. But actually, this source rock has never been deeper, and it's generating hydrocarbons today. So the traps you see today are the ones that will be being filled by the hydrocarbons generated down here in the Triassic. We've not had the data long, but we've put together a basin model which was really trying to compare the Italian side of the basin to the Croatian side of the basin. Things are a little bit more complicated structurally on the Croatian side of the basin, but we've got a lot of, the key point I think is that there's a lot more salt in the section, so we're generating more halokinetic, diapir, salt wall related structures and traps on the Croatian side than really we can imagine for the Italian side. And every one of the little stars up here is a different little play type that we can think of. On the Italian side, relatively few plays are all tested, and we know this hydrocarbon system works, but lots of play types that we can think about on the Croatian side. But all this type of little cartoon, cheer cartoon to me, it's all for naught really. You don't need to do this. You just need to look at this seismic line, because this is the killer for me. Okay, this is down from the southern Adriatic, and it runs from the area near Aquila, which is the Italian oil field, which is located about here on this line. On the upthrown side of the platform margin near Aquila, there's the Giove and Medusa discoveries, which are in this type of location. But it's all really, really shallow. And then you come down into the Croatian side of the Adriatic, and you find that the Adriatic is actually very asymmetric. And that on the Croatian side, not only is your source rock buried a lot deeper, but the fault blocks, this is the fault block that we were looking at before, the fault blocks or the platform margin plays are much, much bigger and much better situated with respect to where the hydrocarbons are, and they have a much thicker sequence sealing mudstone sequence sitting on top of them. So in terms of a comparison between these two basins, yeah, this is the Italian side of the Adriatic, and it works. There's oil being produced commercially on the Italian side. But the really attractive part of this basin is not here. It's here. It's on the Croatian side. And this is all totally unexplored. And it's really up for now for the oil companies to start exploration of this area based on using the right tool. And I think that goes back to the original point, is that if it may be a harder question that you're asking yourself to solve, but if you've got the right tool, you've actually geared up to make the success where previously you couldn't do it. And I would say that, at no point through this am I trying to slag off Ina Naftaplin's efforts of exploration in Croatia. Not at all. The wells that they've drilled, you can understand why they've drilled all of their wells when you look at the data that they were drilling it on. That's the key point. They had the right play model. They used the right plate model in the right place in Croatia, but without the seismic data to allow them to refine where exactly to drill, then they didn't have any success. So it's kind of not their fault, but they're just trying to do something before its time. Well, I'm afraid its time is now, and it's down to you to go and do it. Thank you very much.
And do we know how the licence round went? I mean, who applied, or is that not known yet?
The licence round?
Yeah.
Yeah, the licence round officially opened on the 2nd of April, and it runs for 6 months.
Oh.
So it will close in November.
Okay. So we don't know who's applied, or
No, most of these people, I guess.
Right, anybody else, please? Okay, thank you, Neil. Thanks very much. Right, we're going to move on now.